In this video, we're going to go over angles, arcs, and lines in a circle. There's going to be a few note slides. So for now, just get a snip of each of them, and then we'll go back to little pieces of each note slide as we need it with each problem. This first note slide is what you're going to reference anytime a problem is asking for some kind of angle measure. An angle measure or an arc measure. They're asking for something that's measured in degrees. Come to this slide. The next slide is all about segment lengths. If it's asking for a length of any kind of segment, come to this slide. And there's lots of different scenarios that we can find segment lengths in. It'll be one of these ones. And you'll also have just, I believe, one or two, I think just maybe one question that's just asking about tangent lines. We'll go over this since we don't actually have any problems. Tangent lines, we just want to know the defining characteristics. A tangent to a circle is a line that intersects the circle at exactly one point. It might look like there's quite a bit of overlap here, but that's just our limitations in drawing. It technically only intersects at one point only. The other defining feature is that a tangent line is going to make a 90-degree angle with the radius. So the radius goes from the center of the circle to a point on the circle here. So a tangent line is always going to be perpendicular to that radius. If this angle measure here is 89 degrees, it's not a tangent line. If this angle were 91 degrees, it's not a tangent line. It's got to be 90. So that's one of your questions on your test. Now we'll get into ones where we actually have to solve for things. Here we're asked to solve for x and y. So x and y here are referring to lengths. We want the length of this segment and the length of this segment. So what I'm looking at here is that this is actually a tangent line. If it continued on this way, we would see that it's only intersecting at this point. And this is something that we just have to make a visual assumption of in this case. So we have a tangent line here and a tangent line here. Over here, we've got a tangent line here intersecting at just one point and another tangent line here intersecting at just this one point. So our principle that we're going to use here is the idea that two tangents from a single point are congruent. If I have a tangent line here and a tangent line here, and then they intersect at some point outside the circle, these two segments are going to be congruent, meaning they're going to have the same length. So very simply, if these two tangent lines are intersecting here, that means these two segments are congruent. So x is going to be 21. Same over on the left. They're both coming from this point here. It means they're both going to have the same length. So y is going to be 28. So not too bad on that one. As soon as you know what the principle is that we're looking at, and we're able to visually recognize it in a problem. Next up, we're looking at some angle measures. We're solving for measure of angle BAC. So that's this angle here. This is called a central angle. It's a central angle because the vertex of the angle is in the center. Now this will have a special relationship with what's called its intercepted arc. So this angle reaches out its little arms here and here, and that portion of the circle, like the portion of the pizza crust that's in between its little arms, that's the intercepted arc, and they have exactly the same measure. So in this problem, we're told in circle A, measure of angle, arc BC is 74 degrees. That's saying this portion of the pizza crust, which is also measured in degrees, just as we measure angles in degrees at 74, wants us to solve for this. Well, they're just going to have exactly the same measure. Now, slightly different relationship over here. Here we've got measure of angle CBE is given to us as 41 degrees, and we want the measure of arc CE. So again, we have an angle. This time it's an inscribed angle. We call it an inscribed angle because its vertex is on the circle itself. If he reaches out his little angle arms here, and we look at what portion of the circle he's catching in between them, that's his intercepted arc. So we're looking for that measure here. We're given the angle, and we're looking for the intercepted arc. So there's also a very clear relationship here, slightly different. With central angles and their intercepted arcs, they have the same measure. With inscribed angles, their intercepted arc is double the angle measure. So we take the angle measure, we just multiply it by 2, that gives us the arc measure. So if we take 41 and we multiply by 2, that's going to give us 82 degrees. And that's our final answer for the measure of arc CE. Here we're going to solve for BD. BD is right here. It's this segment here. So it's a segment length. I'm going to go to that slide that has to do with segment lengths, and I'll see a diagram that looks similar to this. I've got chords that are intersecting inside the circle, and there's a relationship between all of these different lengths. So what we have here is if we have one chord, we can take the pieces that it's kind of broken up into. So this piece A times this piece B, their lengths multiplied together will be equal to the pieces of the other chord multiplied together. So if we take this piece C and this piece D, we multiply them together, these products are going to be the same. So if we have intersecting chords and 3 out of the 4 of these individual pieces are known, we can solve for this last one. So what I'm going to do first is I'm just going to call this X, this piece right here. So I'm going to say X times 6 is equal to 10 times 3. So what I'm doing is I'm saying these two things multiplied together are equal to these two things multiplied together. So I'm just going to rewrite this as 6x. This is equal to 30. I divide both sides by 6, and I get x equals 5. Now, just be careful. In this question, you might only have to solve for BE. Okay, BE. Let me erase some of this stuff. Just this little section BE is what I was calling x, and that is equal to 5. But this problem happens to ask for BD. It's asking for this whole thing. So if part of it is 5 and part of it is 6, it's nothing too crazy. I'm just going to add those together. One piece plus the other piece equals the total. That's just going back to our basic segment addition. So just pay attention to, I honestly don't remember which type of problem I gave you, but pay attention to, do they want the whole chord or just a piece of it? All right, now we're going to be solving for an angle measure. We're solving for TVQ. All right, here it looks again like chords intersecting inside a circle, but here I'm being asked about an angle measure. So I'm going to go back to my finding angle measures slide, and I'm going to see something that looks like this. So what this says is that if I'm looking for either of these two angles, 1 or 2, now first of all, notice that those are a vertical angle pair. So they're congruent. So I could be asked for either angle 1 or angle 2, and they're going to have the same measure. So that's what we're seeing here. It's saying measure of angle 1 is equal to measure of angle 2. They both equal all this stuff. So what is all that stuff? It's saying this arc measure plus this arc measure. All right, that's the top section. Those two arc measures added together, and then we just divide them by 2. So here we've got measure of angle TVQ is going to be equal to the measure of arc SR plus the measure of arc TQ. So you just kind of look, you see, okay, this is the angle. Those are the arms of the angle that I'm looking for. And just look, where are the intercepted arcs? You want the two arcs that are between their little arms. Okay, they've got little hands. Oh, how many fingers that is. All right, so the arc that's between one set of little angle arms, the arc that's in between the other little set of angle arms. So it's going to, and we're going to take all that, divide by 2. So SR is 18, TQ is 106, and we've got to divide that by 2. So 106 plus 20 would be 126. Take 2 away, I get 124. That's how I'm going to do that in my mind. And that's going to be 124 over 2. And that's too hard for my brain, so I'm going to do 120 over 2. That's 60. And then do 4 over 2. That's 2. And put them together, and I get 62 degrees. So that's the measure of this angle we were asked for. If we were asked for it, it'd be the same as that. I know this is going fast. Just pause and rewind as much as you need to. All right, we're solving for DE. Where even are we? Okay, so that's change. I'll keep this color. So that's going to be this. Oh, look at that. I don't think we want DE because that would be easy. DE is 4. It's right there. No, I'm not going to make it that easy for you. Okay, but it won't be too bad. Let's change this. We're going to solve for DC. How about that? That's going to be this X value right here. So here, I'm being asked for a length. It's this length right here that's inside the circle. So I'm going to go to my finding segment lengths slide, and I'm going to see a section that looks like this. It looks like a lot, but it's going to be kind of a process of elimination. Okay, because what you're going to see is there's a bunch of stuff happening outside the circle. You're given lengths outside the circle. So if you're given lengths outside the circle, ignore this guy because there's nothing outside the circle here. He can't help you. This 2 tangents from a point is a very specific situation. It's kind of limited. You're going to have one problem on it, and there's not going to be anything to it. I'm going to give you one length, ask for the other one. If it looks like a more complicated problem asking for a segment length, it's probably one of these two. All right, so the difference between these two situations is what type of lines we have. They're both going to use the same formula. We're just going to use it a little differently, and we're going to do one of each. So in one case, you're going to have a secant situation. So this is a secant line. A secant is a line that intersects a circle at 2 points. So here's a point here. Here's a point here. This line here is also intersecting the circle at 1, 2 points. 2 points. So this is a secant, and they're intersecting somewhere outside the circle. This is a secant tangent situation. One of the lines is a secant. It's intersecting here and here at 2 points. Then one of them is just a tangent. When you see a line and it just goes boop and it stops right here, you're meant to interpret that visually as a tangent line and say, okay, there's just one point of intersection here. So for either situation, you're given a bunch of lengths. Some are inside, some are outside. It's going to be one of these situations, but it's going to be the same formula. Outside times hole equals outside times hole. How are we using that? Well, let's go see. Let's go see. All right, so in this case, first of all, let's look at what we have. We have 2 secant lines, right? They're like slicing through the circle and intersecting at 1 point. So it's going to be the same formula, but let's just ignore this so we don't get confused. We have 2 secants. So the main formula is right here. I like to say, ow, ow, right? It's outside times hole equals outside times hole. So what does that mean? It means for one of the lines, we're going to take just the outside section, which is A in this case. That's the length that's outside the circle. That's right here. That's the O in ow. And we're going to multiply that by the whole length inside and outside. So that would be A plus B. All right, so this is the whole. That's going to be equal to, all right, it's ow, ow. So it's again on the other side of the equation, outside. That's here, just C. And then times the whole length, the outside and the inside. So that's here. So ow equals ow. All right, hopefully it doesn't hurt too bad. So let's look at this BE line, BAE line first. All right, the outside is just that part there, that's 8. The whole length, including the inside and the outside parts, so that's O, this is W, is going to be 11 plus 8. All right, so that's going to be 8 times 19. That's going to be equal to, let's look at the other side. All right, the outside is that. All right, so O is equal to 4 times the whole thing. Now, what's that? It's the inside and the outside. Well, the outside is 4 and the inside is just X. So same idea, we're just going to add those together. We don't know what it is yet, but it's going to be 4 plus X. That's the length of the whole thing. So we're going to say those two sides are exactly equal. We're going to do our 8 times 19. and we get 152. And we get 16 plus 4x. So we're going to take our 152 minus 16. We get 136 equals 4x. And we're going to divide by 4 and get 34. So that's this length here is 34. Let's try another one. Now we're going to solve, we are actually going to solve for BD. All right, that's this section right here. Now, just notice first when we were trying to figure out what kind of problem it is, we're looking for segments. So we're going to go over to that slide. And it looks like there's stuff inside and outside the circle. So it's going to be one of these parts in the middle of that slide. So either way, it's going to be ow equals ow. But this time we have one tangent and one secant. So it's just going to be used a little differently. This is still the outside, so that's here. And the whole length is still going to be those two things added together. But for the tangent part, okay, for the tangent line, that's the outside and it's the whole thing. All right, so this is outside times whole. They're both A. So that O is A and W is A. So it's just A squared. So let's look at this problem. We've got this is going to be O for that line. The whole thing is going to be 12. Remember to add them together. It's easy to put 12 in for here, but it's 12 plus 4, so that's 16. And here, this is O and it's W. All right, so it's like X times X. So 4 times 16 is 64. X times X is X squared. Maybe you see where this is going now. All right, if we want to solve both sides for X, we've got to square root this side. That'll give us X, and we got to square root this side, and that'll give us, that's not much of an 8 there, is it? It's going to give us 8. So same formula for the last two problems, just using them a little differently. One more type of problem. I've got some mystery text there at the top. Here, we're looking at things in degrees. So we're going to go to that finding angle measures slide. And let's see what it tells us. It tells us BCA. So that's this whole section of the circle there is an arc with measure 210 degrees. And this section of the circle is an arc with measure 150 degrees. And we are being asked to solve for that angle measure, BDA. So we're going to go to the angle measure slide, and we're going to see that, okay, they're talking about arcs and angles. There are two lines that are intersecting outside the circle. It's another situation where we have one formula for multiple scenarios. So in this case, we have two tangent lines. They're just skimming the outside of the circle. Notice they're not slicing right through it. So it's two tangents. We're going to use this formula. If we had one tangent and one secant, same formula. If we had two secants, same formula. In each case, what we're going to have is kind of in between where these lines are hitting the circle, you're going to have arcs being formed that are kind of in between. I think of it like there's a flashlight here and there's like a beam of light here, and we're looking for the arcs that are in the beam of light. So there's always going to be one bigger one. Okay, it's broken up by where the lines are intersecting the circle, and there's going to be a smaller one. We're going to take the bigger arc minus the smaller arc and divide by 2. That's our formula. If I had a tangent and secant, we've still got our flashlight here. We've got this beam of light, okay, that's just inside the two lines. There's a bigger arc, and then there's a point of intersection here, so that's breaking it up into, here's the smaller arc. If we had two secants here, we've still got our flashlight out in outer space. We've got this beam of light here. And now in between the lines, we've still got a larger arc and a smaller arc. The smaller arc is always the one that's closer to the flashlight. The bigger one is always farther away. Either way, it's bigger arc minus smaller arc divided by 2. That is our formula. So here, 210 is the bigger arc, or according to the formula, arc 1. 150 is the smaller arc, or we're also calling that arc 2. So the measure of angle BDA is equal to arc 1, aka bigger arc, minus arc 2, aka smaller arc, divided by 2. All right, so it looks like a lot, but the arithmetic itself is not too bad. So the bigger arc is 210, minus the smaller arc is 150, and we're going to divide that by 2. 210 minus 150 is 60. We're going to divide that by 2. Our final answer is 30 degrees. So what we're finding here is this angle measure here, that's equal to 30 degrees. That's kind of hard to see. One more problem. We're going to use the same formula. As you can see here, okay, there's lines that are intersecting outside the circle. They're going through the circle. There's some arc measures, angle measures. We're going to go to our finding angle measures slide, and we're going to see this. In this case, we have one tangent and one secant, right? So it looks like that middle scenario in our notes, but same formula no matter what we have. This one is a little different though. It's saying that we're going to solve for measure of arc BA. Oh, I think I meant to write CA. Whoops. All right, measure of arc. So it's this one right here. We're solving for this. If, and I meant to write ABC. I mixed up all my letters. If measure of arc ABC, so that would be from here all the way around. Actually, no. Oh man, I messed this up completely. I'm sorry, guys. All right, real quick. We're going to say it's last problem. Of course, it's last problem. I'm going to change this right here. All right. Solve for measure of angle CA if AB if ABD equals 205 and measure of angle A, I change that letter too. Okay, sorry about that. All right, let's look at this all over again. We're going to solve for measure of arc CA, that's here, correctly labeled. If measure of arc ABD, so that's A, the name is always like a roadmap, just follow the letters. A to B to D, here to here to here, is 205 degrees, and the measure of angle AEC is 75. We've got two arcs and an angle here that are involved. We're going to use the same overall formula, which is the measure of that angle, AEC, is equal to arc 1, remember that's our bigger arc, minus arc 2, that's our smaller arc, over 2. The difference here is going to be what we're going to plug in. So here, we know the angle measure, it's 75. Last time we were trying to find that. Arc 1 is the bigger arc, so that's 205. That's the one farther away from the flashlight. Arc 2 is our mystery number. I'm just going to call it X. All right. Here, let's erase this question mark, and we're going to just decide to call that X. And that's going to be over 2. So how to solve this? The first thing I'm going to do is I want to get rid of that 2, right? Nobody likes fractions. We can all admit that. So let's just multiply by 2 to cancel that out. Multiply by 2 over here. So now I've got 150 equals 205 minus X. All right, here what I'm going to do is I've got 205 minus X equals 150. What you could do is you could just think, well, 205 minus what number is 150? And you'll get 55. You might just think of it kind of trial and error that way. But if we want to make it kind of a little formally a little different, what we could do is we could say, well, this is like minus X. Let's add X to both sides, get rid of it over here. And then we're looking at 150 plus x equals 205. This looks like a little more like what we're used to, right? 150 plus x. So we know we're going to subtract this. Kind of running out of room here. So now we're subtracting 150 from both sides. So we've got just x on the left now, and we've got 205 minus 150 is 55. So a few different ways you could do that, whatever way makes the most sense. You could also, starting from right here, you could subtract 205. I think that might mix some students up because then you're going to get a negative number, but you're going to have negative 55 equals negative x. You can just multiply both sides by -1 and you get the positive. So that's it for today. I hope that helped. If you have any questions, just email me. Bye-bye.